Yeah, hello guys, you're welcome back to my channel. This is Chemistry Core. Today we'll be looking at another topic which I've promised the jam bites this year, and the topic today is chemical equilibrium. Before we go into this topic, I want to appreciate the effort of our subscribers. Thanks for 400 subscribers. We can do it from 400 subscribers to 1000 subscribers. So keep sharing and like. So now, this chemical equilibrium, earlier I've dropped the video and I've explained extensively what is a chemical equilibrium now. So before we go into this chemical equilibrium, what are those things which are to be taught today? So the first thing I will cite today is what we call a reversible reaction. The second one is Chateliers Principle. So now, these two are what we cite first before we move to the factors affecting the position of equilibrium. So let's cite that also. So now, as you can see, the state things now is what we are going to cite this morning, and we'll be solving 10 questions on this chemical equilibrium. Don't forget, I told you guys I've dropped a video on equilibrium. You can straight on to my video to check for the definition of equilibrium and what are the types of equilibrium we have. We have that of the homogeneous equilibrium and heterogeneous equilibrium. So I will summarize those two, then we can move to what we call a reversible reaction. So now, what is a chemical equilibrium? So I can say that the definition of equilibrium is the same thing as that of the what? A reversible reaction. So now, a chemical equilibrium are those that does not have any effects or change in the position of what? A chemical system. So if, for example, now I have A plus B, don't forget this arrow here is used or to represent what we call what? A reversible reaction. So C plus D. So I can decide to revise this to be what? C plus D. I have A plus B. So now, for every chemical equilibrium, the reactant side and product side has what we call a forward and a backward reaction. So this is our forward reaction, while this is our what? Backward reaction. So what is a reversible reaction? So you can say the reversible reaction a reaction where there is no observable change in the position of what? Of equilibrium. Or we can say the reactant side is equal to the what? The product side. So now, the main thing now that as a jam bite you ought to know very well is what we call Chateliers Principle. And what is the effect of Chateliers Principle on the position of equilibrium? So now, let's state this. Now, let's say I have Chateliers Principle. So this principle, this states that if an external constraint such as pressure, change in temperature, concentration is imposed on the chemical system in an equilibrium. So now, if this constraint here and this external constraint here, as I've said earlier, that is imposed on the chemical system in an equilibrium now. So what will be the effect of the Chateliers principle on this external constraint, such as temperature, concentration, and pressure? So now, if it is an equilibrium, now the next thing is the equilibrium will shift so as to annul or neutralize the effects of equilibrium. So now this is the Chateliers principle now. So how do we explain the effects of the Chateliers principle on equilibrium now? For example, if I have A plus B, a reverse reaction, we have C. So this you have here. Now let's take a look at the external constraint now. And what do we mean by this particular constraint? If there is no what? There is no change or the effects on a particular system now, such as change in temperature, concentration, and pressure, or we call it total pressure now, is imposed on the chemical system in an equilibrium, the equilibrium will shift so as to annul or neutralize the effect of equilibrium. A plus B, we have C. If this C, we have change in H, is positive. Are you with me now? And we also have this to be C, A plus B, negative now. So how does it impose on the equilibrium? Like this now. It can take us to what we call the endothermic and exothermic reaction with this now. So if it is positive, the effect of the Chateliers principle on this now, it favors the forward reaction of an endothermic reaction, and if it is negative, it will favor the forward reaction of an exothermic reaction now. So you can see that it will neutralize the effect of equilibrium to shift to either left or right. From the right hand side, which is positive, I have it to be an endothermic reaction. From the left hand side, to be the effect of equilibrium, I have it to be what? An exothermic reaction. So if you are to talk about this, the Chateliers principle, then we have to touch these factors affecting the position of equilibrium. So the first one that affect the position of equilibrium are what I have cited here, that an external constraint. So the first one which we talk about is effects of temperature. The second one is change in pressure. The third one is concentration. So now we have the last one, which is called as what? The catalyst. So this catalyst does not have any effects. So this catalyst does not have any effect on the position of equilibrium. Rather, it only decreases the time taken to attain the position of an equilibrium. So now we have understood the concept of this, the Chateliers principle. So now let's pick the factors that affect the position of equilibrium one after the other. Then after this, we'll move to what we call equilibrium constant before we can cite the 10 questions from those preparing for JAMB. So now, I will leave this like this, then I have to write this. So don't forget, we are talking about the factors affecting a position of equilibrium. So as I've said earlier, I'm starting with the first one, which is temperature. So we are starting with temperature. Before I will go into this now, don't forget I told you guys that the external constraint under the Chateliers principle are the change in temperature, pressure, and concentration. So let's see how they impose on the position of equilibrium now. So for example, for this, consider the following equation. So I have x plus y, I have z is equal to positive, I have a plus b, I have c change in negative. So now listen attentively now to see the effect of the Chateliers principle on this. So now we said if change in H is positive, the forward reaction is an endothermic process, and if change in H is negative, the forward reaction is an exothermic process, or we call it reaction. So now let me explain this in details. If change in H is positive, the forward reaction is an endothermic reaction. That is this. Here we have endo to represent our endothermic process. So this is our forward reaction. While this, that is the reverse reaction of this, we have what we call exothermic reaction. So for every equation given to you in your JAMB, if it is positive, the forward reaction is always endothermic, while the reverse of that is exothermic reaction. So let's take a look at the second one now. A plus B, we have the reverse reaction, the arrows. So C, change in H, we have a negative sign here. So telling you guys that if change in H is negative, the forward reaction is an exothermic process or reaction. So now for this now, you can see that I have exo, while for this I have endo. So are you with me now? So that is just a little explanation on what we mean by temperature. So the next thing we want to do now is, what is the effect of the Chateliers principle on this? So now I can say, according to the Chateliers principle, so we can say, now we want to take a look at these two to determine the effects of the Chateliers on temperature. So now, according to the Chateliers principle, the forward reaction which is an exothermic process, favors lowering temperature. That's the first observation from the Chateliers Principle. The one with negative sign, that is, as I've said earlier, if change in H is negative, the forward reaction is an exothermic process. So now, according to the Chateliers, we talk about the external constraint states that the one with an exothermic process which favors the forward reaction now, it gives us a what? Either decrease in temperature or lowering temperature. So now, let's take a look at the second one. The one with the forward reaction, let's put it that way. The forward reaction which is an endothermic process favors increase in temperature. Fine. These are the effects of the Chateliers now. So anyway, you come across a question, be it this, we have this, and the sign show that this sign here, if it is positive or if it is negative. You should know the effect of the Chateliers on any equation given to you. If it is positive, you know that there is what? Increase in temperature. But if it is negative, there is decrease in temperature. So that is explanation on the position of the Chateliers on temperature. So now, let's cite the second examples now. Second one. Second one is change in pressure. So now, what is the effects of the Chateliers on change in pressure now? So you can say if for a change in pressure to affect the position of equilibrium in reversible reaction, the following condition must be satisfied. So the first one, so I can say for a change in pressure to affect the position of equilibrium in reversible reaction now, there are some certain conditions we ought to understand before we can determine the effect of the Chateliers principle on change in pressure. The first one is the reactants or product side must be gaseous. That's the first thing. So if we are given an equation and the reactant side and product side is having two different equilibrium states, that of the homogeneous and that of the what? Heterogeneous, which I have explained in my former video. So guys, don't forget to subscribe as you watch. So now the second one is the number of mole volume in a gaseous molecules must be different on the reactant side and products side. So they said the number of mole in the gaseous molecules must be different on the reactant side and product side. That is, the number of mole we have at left hand side must also be different from the one we have at our right hand side. So for example now, I have, okay, SO2 plus this so if I'm adding 2 here, I will also add 2 here. So now this is balance. So let's take at the number of moles I have at my reactant side now. So this is my reactants and this is my what? My products. So the number of moles I have here is 2, 1 here, so we have 3 moles. And here I have what? 2 moles. Are you with me now, guys? So this shows that for what we have here, which are the conditions, is applicable to the what? The equation given. So now, if gaseous, 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 you can see that this equation obeys the conditions which must be satisfied to understand the concept of change in pressure in the position of an equilibrium now. So the first one is reactant side and product side must be gaseous. While the second one is the number of moles on the gaseous molecule on must be different on the reactant side and that of the product side. So you can see now we have 3 moles here, we also have 2 moles here. So now at the left hand side I have 3 moles, at the right hand side I have 2 moles. So now listen to the effect of pressure to the position of what? Of an equilibrium. With what you have on the board now. Listen. The one with less number of pressure, less number of mole of volume, according to the Chateliers Principle, according to the Chateliers Principle. So I said the one with less number of mole. So let me write it here so make it bold so you can have a clear picture of it. This place now. So the one with less number of mole give rise to increase in pressure and we shift the equilibrium to either right or left. So now class, the one with less number of moles give rise to increase in pressure and shift the equilibrium to either right or left. Why I'm using either right or left is that in some cases the one with less number of moles can be at the left hand side. So if there is increase at the left hand side, it's telling you guys that the equilibrium will shift to the left hand side. So now for this equation given here, the equilibrium will shift to the right hand side because we have the one with less number of moles. So now the reverse is the equation. So the one with high number of mole give rise to decrease in pressure according to the Chateliers. According to the Chateliers. So now, earlier I explained the change in temperature. Now, so what you have here, there you guys, and give you a clear picture of the effects on pressure which affect the position of equilibrium. Now, don't forget that for every change in pressure, the reactant side and product side must be gaseous. That's number one. The number of moles on the reactant side and product side for the gaseous molecules must be different. And the effect of Le Chateliers states that the one with less number of moles on either the left or right hand side will give rise to increase in pressure, while the one with high number of moles will give rise to decrease in pressure. So now let's take the last one, then we'll move to the equilibrium constant. So the last one is concentration. So we have third one, concentration. So I can say for a change in concentration, of a substance, for a change in concentration of a substance in an equilibrium, will increase the change in order of reaction. So now, for a change in concentration of a substance in an equilibrium, we increase the change in order of reaction. So, by Le Chateliers principle, the position of equilibrium will move to decrease the concentration of the added substance. So now you might not get a picture of this now, but note one thing, that for every change in concentration of a substance in an equilibrium, we increase the change in order of reaction. So that is, now if I have nitrogen gas plus oxygen gas, then I have this. So please look up. As you can see this now, this, they are family of homogeneous equilibria, because the reactant side and product side are in the same phase. So now, what is the effect of Le Chateliers in the position of this now? Listen, by Le Chateliers principle, the position of equilibrium will move to decrease the concentration of the added substance. So now, this is this. If extra oxygen is pumped into the system, again, if extra oxygen is pumped into the system, the position of equilibrium will shift to the right. And if we are to remove the extra oxygen from the system, the equilibrium will shift to the right hand side. Sorry, to the left hand side. Again, if extra oxygen is pumped into the product side, the position of equilibrium will shift. Or if you are pumping it here now, it will shift from left to this. But if you are pumping it to the right hand side, it will shift from right to what? To left. So that is the reason why the calculator cites that the position of equilibrium will move to decrease the concentration of added substance. But for every change in concentration of a substance in an equilibrium, we increase the change in order of reaction. So that is the effect. So now, for example, now I have A plus B, I have C plus D. So if these stand for increase in concentration of A and B, then this will stand as the effects equilibrium. So you can say proportion option C and D increase and move or shifts the equilibrium to the right. So the increase the concentration of A and B now, we give rise to what we call proportion of C and D increase and shift the equilibrium to the right, because here is our right hand side, Y is our what? Left hand side. So now if you are given an equation now like this, I can tell you guys that the proportion of NO will shift to the right hand side because I'm adding extra oxygen, or I'm pumping extra oxygen into this. So now the next thing is increase in concentration of C and D. The proportion will decrease and shift the equilibrium to the left. Are you seeing this now? Again, increase in C and D. What will be the effect of equilibrium? The proportion A and B will decrease and shift the equilibrium to the left. So that is that for the factors affecting the position of equilibrium. As I've said earlier, that catalyst does not have any effects in the position of equilibrium. Rather, it only will decrease, or it only decrease the time taken to attain the position of equilibrium. That is for catalyst. So now let's take the last one, then we'll move to the 10th question, which I promised those that are writing down this year. We'll call it equilibrium constants. So now, what do we mean by equilibrium constants? So let's take a look at the law of active mass on this. It states that at a constant temperature, okay, at a constant temperature, the active mass is proportional to the reactant side. So now, if I have A, so let's see how the active mass is proportional to the reactant side. A plus B so this scale represents C, the equilibrium constant. So with this now, I can say I'll be using this sign this close bracket to represent our concentration. So I can say the concentration of P product side divided by the concentration of the reactant side. So now these small letters you have here stand as the number of moles. So now Kc, here I have C, the moles will be the power, multiplied by D, small letter D stand for the moles, divided by the reactant side. I have A here, also I have B here. So now this is a clear picture of what we call equilibrium constants. So now class, I've explained in details what the Chateliers Principle is all about, the factors affecting the position of equilibrium, the equilibrium constants. Now let's apply all these to the 10th question you'll be asked as a jam bite. We have more questions, but I'm solving 10. If you have any issue as a subscribers, you can drop your question in my comment box. Thank you. So now let's start with the 10 questions. So the first one I will pick, yeah, JAMB 2005. So JAMB 2005, we have this. So with what you have on the board now for the JAMB 20 question, said in the reaction above, this is my number one, in the reaction, or you can say in the equation above, the yield of ammonia can be decreased by dash. A, increasing the pressure. B, removing ammonia as it is formed. C, increasing the temperature. D, adding catalysts, adding a catalyst. So now, in the reaction above, the yield of ammonia can be decreased by, okay, look up, which this now, this is telling you guys that that negative sign here is an exothermic reaction. Exothermic reaction, and anything that is an exothermic reaction, don't forget that under, when I was explaining the effect of temperature according to the Chateliers, the one with negative sign which favors the for reaction, there is decrease in temperature. So now they said in the reaction above, the yield of ammonia, this is our ammonia, can be decreased by what? Here we have, so now this one we have 1 mole here, we have 3, so this one is 4 mole. and here I have what? 2 mole. So now let's take it one after the other. The effect of temperature on this shows that there is decrease in temperature. Now, what is the effect of temperature, on pressure on this now? Don't forget that I said the one with less number of moles of volume give rise to increase in pressure. And it states in the question that the yield of ammonia can be decreased by A. Increasing the pressure, removing ammonia as it is formed, increasing the temperature, adding the catalyst. D is not there, B is not there. So my answer is between A and C. So a question like this, you don't have to rush. You have to calm down. You look at this. Don't forget that when I explain the time maximization as a jambite, I said you have to think and drop and pick your answer for just 30 seconds. So like this now, if you have understand the concept of what we call by equilibrium, then your answer is very simple. The yield of ammonia can be decreased by increasing the pressure. Why? Because the number of mole here is 2 at the right hand side, here at the left, which is 4. 1 plus 3, we have 4 moles. So there is what? Increasing. If I'm to what? If there is decrease in ammonia here by increasing the temperature or increasing the pressure. So now my question is, if I'm picking the increase in pressure, why am I not picking what? Increasing the temperature. Question like this is very, very technical. The yield of ammonia can be reduced, can be decreased. So when you decrease ammonia now, are you with me now? When you decrease it, what is the effect on that? So my answer for this is increasing the temperature or increasing the pressure. So our answer is increasing the temperature as the ammonia is yielded. So your answer is this. So let's take a look at another example. So after this, we have 8 more to tackle. Okay, I said this JAMB 2004, which of the following shows lead to or no net reaction when the volume of the system is decreased? A plus B C D So with what you have here now, which of the following shows lead to or no net reaction when the volume of the system is decreased? So a question like this, I would advise you, check the number of moles and which one does not have any effect. The first one here I have 1 we have 2 mole here, 2 moles, 2 moles. Here I have 2 moles. I have 1 moles here. So here I have 1 mole. I have 2 moles. We have 2 moles here. And we have what? 3 moles. So they said which of the following shows little or no net reaction when the volume of the system is decreased. Here 2 moles, 2 moles. B, 2 moles, 1 mole. C, 1 moles, 2 moles. D, 2 moles, 3 moles. So the one that shows no net reaction when the volume of the system is decreased is A. You can see. So now let's pick another one, number 3. JAMB 2001. We have this. Minus 189 kilojoule per mole. So they said the equilibrium constant for the reaction above is increased by A, increasing the temperature of the system. B, increasing the pressure of the system. C, the addition of a catalyst to the system. D, increasing the surface area of the vessel. So now with this now, they said the equilibrium constant for the reaction above is increased by increasing the temperature of the system. B, increasing the pressure of the system. C, the addition of a catalyst to the system. So when I was explaining the effect of the equilibrium and the effect of the Chateliers on the external constraint, I did not mention the surface area, so D is not there. And mind you, catalyst does not have any effect on the position of equilibrium. C is not there. So my answer is between A and B. Mind you, there is what we call choice of answer. A and B can be the same thing as your answer, but we have most correct and correct. So now let's which one is most correct between A and B. Increasing the temperature of the system is wrong. Why? Because that equation is a negative sign. And if it is negative, mind you, I told you that for every negative equation given, there is decrease in the position of equilibrium. But if there is increase, it is what? Positive. So A is wrong. So why is B the correct answer? Because when I was explaining the change in pressure, I said the one with less number of moles of volume give rise to increase in what? Pressure. So they said the equilibrium constant for the reaction above is increased by increasing the pressure of the system. So that's the answer. So now let's pick the fourth one. fourth one. In the equation above, the equilibrium constants is given by A, F, E, Q, P, C, D, so now looking at what you have on the board, don't forget when I explain the equilibrium constant, I cite an example. So I said product divided by the reactant side. Why at the product side, the number of mole given there will be the power. So here, E, this is my reactant side, so A is wrong. B doesn't have any power, B is wrong. C is similar to the example I cited when I was explaining the equilibrium constant. So what you have here now, this is my product divided by reactant with the number of mole. So your C is your correct answer. Let's take the 5th one, and we have 5 more to go. So before we move, this question is JAMB 1997. JAMB 1997. So the next one that we can play with, another one, I have N2O4 JAMB 2011. Positive, gaseous. So they said in the reaction above, an increase in temperature will dash it increase the value of the equilibrium constant. B, decrease the value of the equilibrium. C, increase the reactant production. D, shifts the equilibrium to the left. So now They said in the reaction above, an increase in temperature will dash increase the value of the equilibrium constants, B, decrease the value of equilibrium constants, C, increase the reactant production, D, shift the equilibrium to the left. So now, we're looking at what you have on the board here. So let's look at it now. The effect of temperature on this is increase in the position of equilibrium. The effect of pressure on this, there is increase at the left hand side. Are you with me now? But I said in the reaction above, an increase in temperature will dash. An increase in temperature will dash. Will it shift it to the left or to the right? So now that's the question. So as I've explained in detail the factors affecting the position of equilibrium now, so I can pick any answer. So any answer I want to pick, I have to back it up with a good point that this is a correct answer. A states that increase in the value of the equilibrium constant. Okay. D, decrease the value of equilibrium constant. D is not there. This B is not there. C, increase the reactant production. Shift the equilibrium to the left. So if there is an increase in temperature, we what? Increase the value of the equilibrium constant, because we said increase, not decrease. So my answer is A. So the next one, I don't think I have much question here, but let me play with like 3 or 4 more, even if it doesn't up to 10. So my subscribers, if I jam bites, kindly go into my comment box to drop the question you have issues with, and don't forget to subscribe, and always watch to the end, like, dislike, and comment. So now let's take another examples now. Our question on equilibrium. Okay, 2008. In the reaction above, the equilibrium constant is B, so this question is very what? Technical, because based on what you have on the board, the I said, what is the equilibrium constant here now? This does not carry the power, so A is not among. B, the number of moles should be represented here, not inside the concentration bracket, so it's wrong. So my answer is between C and D. This is my reactant side. Instead, this is supposed to be here, while this is supposed to be what? Here. So my answer is D. To obey the equilibrium constant. So let me solve these 2 more. Don't forget JAMB 2008. This is what? The solution to it. So I have 2015 here and 2019. So these are the two questions I'll solve. So when JAMB 2015, when at equilibrium, which of the action below we shift to the right if the pressure is increased and the temperature is kept constant. They said when at equilibrium, which of the following reaction below will shift to the right if the pressure is increased and also the temperature is kept constant. So now let's take a look at this. A. B. C. D. So now look at this question. When at equilibrium, which of the following reaction below will shift to the right if the pressure is what? Increased. So now the first thing I'm going to do here is that let's look at the one with increase in pressure. Here we have 2 moles. Here we have 3 moles. And don't forget here is always our left. And from the question, they say right. So this is my right. So the effect of pressure here, there is an increase in pressure at the left hand side. So let's take a look at this. We have 2 moles. We have 3 moles. Same thing here. Increase at the left hand side. Here we have 3 moles. And here I have 2 moles. I have 2 moles. I have 2 moles. So here there is no effect. So this is out of this. There is no effect on this. But my answer is between A, B, and C. At the left hand side here, there is increase in pressure, but the temperature is constant here. Here, the temperature is constant here. There is increase in pressure at the right hand side. But the question states that we shift to the right if the pressure is increased. So here is my right hand side, here is my left hand side. So the increase in which the pressure will shift to the right is C. So my answer is C. Take note of that. So the last but not the least, so they said this so JAMB 2019. So I can say the reaction above can only attain equilibrium. Wow. Can only attain equilibrium if a gaseous reactant is added, okay, one of the products is removed. C, it is in a closed system. D, it is in an open system. So now, the reaction above can only attain equilibrium if and only a gaseous reactant is added, one of the products is removed. So now, with what you have on the board now, so let's play with the three factors that affect the position of equilibrium. I have 1 mole here. I have 2 moles here. There is increase at the what? Left hand side. So now, and here we have solid, we have gaseous, we have gaseous. This kind of equation belongs to an heterogeneous equilibrium, which I've explained on when I dropped the video on definition of equilibrium and the types of equilibrium, and also how to prove the equilibrium constant. So, and the question is it a closed system? Is it an what? Open system? If we are to talk about the closed and open system, then we have to have talked about enthalpy and entropy. So C and D is not the option. So my answer is between A and B. And they said the equation here, we attain equilibrium if and only the gaseous reactant side is added, one of the reactant side is removed. A and B. If one of the products is removed here, we are left with ammonia and ammonium chloride. So without attaining an equilibrium, because we are having G. So for it to have removed, there will be what? Decrease at the product side. But a gaseous reactant is added. If I'm adding a gaseous reactant here, what will be the effects of the equilibrium on it? Or how will it attain equilibrium? And don't forget that for it to attain equilibrium, we have to check, balance the reactant side and product side. Which one is lagging? Either the solid, liquid, or gaseous phase. So now, my answer is that one of the products is removed, because if I'm to look at the effect of concentration here, this is my increase in concentration, the proportion of ammonia and this will increase at the right hand side. If there is increase here, the proportion of ammonium chloride will decrease at the left hand side. So telling you guys that one of the products must be removed for it to attain the equilibrium. So my answer is B. So guys, don't forget to subscribe, watch, like, and if you have any question pertaining to equilibrium as a jambite or as student in college or higher institution, feel free to drop it to my comment box. Thanks for watching, guys.